Okay, so let's dig into this a little bit. At the bottom left, that's where I want to start. It's the things I don't want to forget just because it's some space for us to draw a little bit, okay? Here was the situation. When we draw that first line, it had that slope of -2. It looked kind of like that. Wouldn't you agree? And we knew that the slope of that was -2. I'm going to use a different color just to kind of highlight a difference, but you can just totally use your pencil or pen, whatever you're trying to use right now. That's fine. I'm going to draw another line right next to it, and I want you guys to answer a question about it, okay? Here's that line that I'm drawing. What do you guys think the slope of that other line is? What you thinking? Okay, so I'm hearing it from multiple places. Why would this also be -2? They're parallel, right? If lines are parallel, that means, well, they have the same amount of change for the both of them. They're going in the same direction, exactly, right? So that's also -2. And so that tells us something. I'm going to use this symbol right here. You see these two like vertical little like dashes? That means parallel. Okay, that means parallel. Parallel lines have the same slope. That's even the first thing it says right there in the notes at the top left. It says parallel lines have the same slope. Okay? So if we know the slope of one line and it says, okay, make a parallel line that's near it, well, then those slopes are going to be the same, right? Yeah. Okay. Before we move forward, what questions do you have about that idea of parallel lines and same slope? Okay. Now, visualize this. Instead of drawing the green line like that, I'm going to draw kind of the same sort of thing I had, -2. That's my slope there, right? Slope is -2. Except this time, I'm going to draw the line kind of like what we saw in that example that we just did at the boards. Instead, I'm going to draw it kind of more like this, right? Where we noticed it even formed a right angle right there. So there is, in this case, an intersection. Well, if I were to come up with a symbol to represent what's going on here, instead of me using the parallel little dashes, this time I'm going to do something more like that, because that's kind of what I'm seeing. It's like a capital T, but like upside down. It looks like I could probably draw like a tiny little right angle in there. This symbol, if it's not parallel, what was the other word we used instead? Yeah, perpendicular. Okay. So if we know that the slope of this was -2, the first line we made, what was the slope of that second line we had to make? 1/2. The slope here is 1/2, which kind of makes sense if we think about it. It has to be positive because it looks like that green line is increasing. It looks like it's a positive change. It's increasing. Well, when we changed it from the -2, and you even noticed I kind of wrote it like this, -2/1. If you've never seen this before, I want to be the one to tell you, every whole number, or like any of those countable numbers, can be written as that number over 1, okay? Because every number divided by 1 is just itself, okay? What I'm getting at is, in order to get the 1/2, we changed the sign and flipped. We flipped it. Instead of 2/1, it's 1/2. We changed the sign, so if it's negative, it's positive now. And you flip it. Okay? Now, there is a name for this, too. This is the next new name for us with this slope. You might have seen this before, and if you've seen that, that's awesome. If you've not, this is what I'm talking about. This process is called a negative reciprocal. It is a weird sort of fancy phrase for exactly what I have right there. Change the sign and flip the fraction. Here's why it's called a negative reciprocal, okay? If I take negative 2 over 1 and I multiply it with 1 over 2, if you remember, when we multiply fractions, we multiply the top, we multiply the bottom. What's 2 times 1? 2, right? And then what's 1 times 2? 2. What's 2 divided by 2? 1. But again, there's the 1 negative, 1 positive here. So it's going to be what? Negative 1 is my answer. A reciprocal is a number that when you multiply it with its original number, it gets positive 1. We don't get positive 1 here. We get negative 1. Hence why it's called a negative reciprocal. It's a negative version of the number that multiplies to get 1. So that's just why it's called that. But for us, what we need is to know the perpendicular slope is a negative reciprocal. And that's exactly what this says. Perpendicular lines have negative reciprocal slopes. And it even defines it. Negative reciprocal means change the sign and flip the fraction. So, some examples to kind of see what I'm talking about, right? If the slope was 3 over 4, well then flip the fraction. Instead of 3 over 4, it's what? 4 over 3, right? I flip the fraction and change the sign. So if it was positive, what do I change it to? Negative, right? Negative 4/3 would be my negative reciprocal, okay? What if I had the positive 2? Well, change the sign, flip the fraction. 2 over 1 becomes 1 over 2, and instead of positive, it's also negative. Okay. Last idea, then we'll try practicing with a couple examples. Here's a question. You guys kind of talked about this a little bit. Remind me, what was your answer that you said, what is slope? What is it? Yeah. It's some sort of amount of change, right? You said the speed. It's how fast does it go up and to the right or down to the left, right? So if I'm thinking about this, here's what I'm getting at. If I have a line that is like completely flat and horizontal, you see that? It's like a completely flat line. You guys tell me, does that increase upwards at all? Does it decrease downwards at all? So does it change at all? It stays flat the whole time. I don't have it increase at all. I don't have it decrease at all. It just doesn't change. And if it doesn't change, what's its slope? 0, right? So my slope of a straight horizontal line is 0. I'm going to rewrite that a little bit. I'm going to say instead of 0, I'm going to write it like I've been doing with that whole fraction thing, 0 over 1. Right? Because 0 divided by anything is just 0, so that's fine. Now, what would a perpendicular line look like for this? To make it the 90 degrees, what do I do? If the line's completely flat left and right, how do I make a line that makes 90 degrees? Don't I, just go straight up and down, like that, to make the 90 degrees. So let's take that negative reciprocal idea to find the slope of that. I need to change the sign. So if it's this, what's the sign going to be? Wait, 1 over 0? Am I allowed to do that? Am I allowed to divide by 0? You guys tell me, am I allowed to divide by 0? We could probably try it with a calculator. Let's see. Let's go on to Desmos real quick and try. Let's do 1 divided by 0. It's saying there's an error. Let's look at the notes a little more clearly right here. It says right here, if I have a slope of 0, as in talking about a just straight left and right line, right? Well, then its perpendicular thing, the line that makes it perpendicular, that goes up and down, has an undefined slope. Okay? I'll put this here. You're welcome to dig into this if you want. What this means is it increases infinitely and decreases infinitely both at the same time. And that's a problem. Right? It goes super high and super down. Infinitely all the time. So, of course, how do you measure that? You can't. Right? It's undefined. Okay? And that's exactly what this says. Horizontal lines have 0 for their slope. Vertical lines have an undefined slope. Because 1 divided by 0 is not possible. Okay? So, what questions do you guys have about parallel perpendicular slopes? Any of that? Okay. We're going to look at example 1 now. It says determine whether the lines AB and CD are parallel, if they're perpendicular to each other, or they're neither. So first, let's just try to draw these and see what we see, and then we can use the math to verify that, okay? It says A is at 3, 6. So if I'm looking at where A is going to go, it's probably 1, 2, 3, and then 1, 2, 3, 4, 5, 6. So right here might be A. There's A, at 3, 6. B is at what, negative 9, 2? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then positive 2. So there's B. I'm just going to grab a ruler here and trace that between each other. We have 2 points, so we can make a line. There we go. Perfect. Something just about like that. That's A to B. So let's find C to D. C is at 5, 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. There's C. And D is at 2, 3. So 1, 2, 1, 2, 3. There we go. So again, I'm going to trace that over. There we go. So just by tracing these, what do those lines look like? Do those look parallel, perpendicular, or neither? They look parallel. They're looking like they're going in the same direction and they don't ever touch, right? So let's verify that. Let's find the slopes of both of them, and if the slopes do match up, they're like the same slope, then they got to be parallel. If they're negative reciprocals, then they're perpendicular. So the slope of A to B, well, I could count it. Let's go 1, 2, 3, 4. It goes up 4. And then it looks like it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So A to B, that slope, looks like 4 over 12. And that's if I do the counting thing. But like I said, I want to show you this other way using the other equation, so let's look at that. For C and D, we need to choose our x's. What are my x's for C and D? 5 and 2. I'm just going to put the little x's above these just to symbolize, okay, I've got my x's. And now I need my y's. What are my 2 y's? Yeah, the other ones, 4 and 3. So y and y. Do I start with 5, 4 or 2, 3? You tell me. 2, 3. So I'm going to put little 1s right next to the start. I'm going to put little 2s right next to the end. Okay? So I have y2 minus y1. So 4 minus 3. And then what's my x2 minus x1 in this case? It says x2 is 5, and then x1 is 2. What's 4 minus 3? I'll ask that again. What's 4 minus 3? 1. And then 5 minus 2? 3. So the slope of C to D is 1/3. 4/12. Can I simplify that? I know I'm allowed to simplify some things. Is that possible to simplify? What could I simplify 4/3 to, or 4 over 12 to? 1/3, right? 4 divided by 4 is 1. 12 divided by 4 is 3. Oh my goodness. the slopes match. So if the slopes match, is it parallel, perpendicular, or neither? I think they got to be parallel, yeah. The slopes match. So if the slopes match for my two lines, they're parallel. Now this lets us do something kind of cool. You ready? Example 2 will take us no more than 2 minutes to do all 4 of these, because we know some patterns now. Here's the question. It says, write an equation of this line right there that is parallel and perpendicular. So let's start with the parallel. What does the parallel slope have to look like for this? Look at the equation. What's the parallel slope got to look like? Negative 1/4, right? And what's the perpendicular slope got to look like? Well, remember, if it's perpendicular, you flip the fraction and you change the sign. So it's positive 4/1, and isn't that just 4? 4/1 is just 4. Boom, and we've got our slopes. So now we make an equation. An equation of a parallel line has the same slope. So it's y equals negative 1/4 x. And then I think about, well, what's my y-intercept here? We want to be a little careful. Think about it. If I have a line right here, and then the parallel one is like next to it, do they have the same y-intercept? No. Does it matter what the y-intercept here is in this case? It doesn't really say it goes through this y-intercept or anything. It doesn't say that. So I can just choose a number as long as it's not 6. Because 6 would mean it's the exact same line, one on top of the other. So I could just choose 5. That's fine. Or negative 2 or whatever other number as long as it's not 6. Okay? So what could a perpendicular equation look like here? What could that look like? Sure. If it's perpendicular, does the y-intercept matter? Right. Here's an illustration of what I'm talking about. Here's a line right here, and then here's another line. If it's perpendicular, does it matter where it is? No, as long as it stays perpendicular, right? So what I'm saying here is I can just say 6 is also my y-intercept in this case, as long as my slope is the perpendicular thing, okay? Let's try that again. Parallel slope for y equals 3x plus 2. What's the parallel slope here? 3. It's just the same number. What's the perpendicular slope got to look like? It's got to be negative this time. We've got to change the sign. We also have to flip the fraction. 1/3. So let's write this. What's an equation of that? Parallel equation. Yeah, 3x. And then as long as it's not 2, right? I could say plus 1, plus 0, plus 45. It doesn't matter as long as it's not 2. And then the last one, perpendicular slope. What would that equation look like? Sure, negative 1/3 x plus 2. Like I said, this wouldn't take too terribly long now that we know the patterns. So here's what this means for us right now. Tomorrow, we're going to leverage this resource to talk about one more important concept, which is this. I think you saw this a little bit on that homework when you started it yesterday, was what if I have a slope, and then it asks me, make an equation of a slope and then this given line. Okay, we're going to talk about that idea tomorrow. So keep this with you. We're going to leverage this tomorrow. So I do hope you guys have an excellent rest of your guys' day.